You know, we're living in this very interesting times. I think someone can always say it will always be interesting times. But the fact that we have this technology to be together virtually is amazing. I know it would be so much better to see you all and interact with you all in person. So again, I'll work with this virtual media, but I hope this works. Anyway, I had put together a slide deck of a few things in my life in science. I like to call it adventuring in science, but sometimes it's misadventuring in science, and that's okay. I mean, I was young once, and I still like to consider myself young at heart as well. When you embrace this lifetime approach to learning, like, I know I will never know everything, but I am so hungry to know so many things. It opens up all these possibilities that I never even imagined. When I was 10 years old, yeah, I was a good student. I studied a lot. I spent a lot of time in the library because we didn't have, now we have the internet, which is the most amazing thing on the planet. But when I was young, I soaked up everything I could, and I wouldn't have imagined that I would be building spacecraft and payloads that have gone to different places in the universe. And it's just been an interesting and fascinating road to get there. So I have an interesting employer, NASA. It is cool. It's cool working for NASA, and the interesting thing about it is I am surrounded by a lot of amazing people who open my eyes to new and different things. In fact, my years working at NASA, I have been exposed to so many different problems. So I've been solving problems in space and aeronautics, and there's so many out there more to be solved. And you know, each step builds upon each other. But and through all of this, I've had my adventures and my misadventures, learning along the way. I was trained as an astronomer, and as an astronomer, we go to pretty interesting places. I was observing on telescopes in Hawaii on the top of an extinct volcano at 14,000 feet. And you know, that's where it's dry, there's no trees, but it's where we can observe the infrared universe. Infrared is just a different part of the light spectrum. But there I am in the control room with my cup of tea, looking at data. And the science I was doing for several years was studying clouds, where baby stars eventually would be born. In particular, we were interested in measuring the properties of those clouds, and in particular water, because water becomes a bridge to understanding the origin of us, the origin of life. We still don't know how life came to our planet, how life exists perhaps elsewhere in the universe. You know, these big questions have yet to be solved, but it's been fun adding my little element to several of these papers on studying water in the nascent stellar nurseries. I've continued a lot of observations, but this time I've gone for a telescope on a plane. They cut a hole in a 747 aircraft and put a large telescope about the size of the Hubble Space Telescope, and we fly above the Earth's atmosphere. This allows us, and we can also fly from very places all over the world. Right now, the plane is in Germany flying over Europe. And by being up at around 40,000 feet, a little higher than a normal aircraft, we're above a lot of the water vapor in the atmosphere, and we can see deep into the universe. We can see deep into places that are obscured. And this is a picture of a ring of dust around a supermassive black hole at the center of our galaxy. Again, we don't know why our galaxy has a supermassive black hole that's gobbling up stars, but it is a fascinating understanding about, you know, the physics of our nature of the universe. And we also do a lot of spectroscopy, trying to understand the molecules that are in our universe. Again, trying to piece together the chemistry to know what we're made of and where we came from. And hopefully this will inform us, you know, where we're going next to understanding our life in the universe. I've had a couple of experiences on microgravity. I designed several experiments. The one in the front in the box was trying to understand how planets grow. We basically took grains of sand and different types of rocks and put them in a microgravity environment, which is made by us going in a plane, and we would go up and we would go down. So we experience microgravity and a lot of gravity. And I was also doing another experiment working on a handheld ultraviolet camera. And I show, of course, my biting my lip and sheer concentration when I'm right there in an experiment. That's all my focus. And also my ungracefulness, if you can see me, losing control and just bouncing around the cabin, which was also fun, but after a while got tired because we would do about 45 parabolas in a voyage. So you would go up, go down, go up, go down, and then you'd have to pace that out. But it was quite a very interesting science happens when you remove gravity. When you remove gravity, a whole bunch of other properties take over. Van der Waals force, which is a reaction between the electric potential of atoms, that dominates. And then in biology and pharmaceutical sciences, different gene expressions occur. So there's a lot of amazing science out there in the microgravity. And they do a lot of these experiments on the International Space Station, which is at the zero gravity. But if you can't get to the International Space Station, you have these vehicles to do the experiments to just get that science ahead. It is an amazing adventure. I had a fun job once for NASA. They paid me to destroy things. I was asked, we need to fly some things in space, and space has a harsh environment called radiation. It can come from the sun. Our Earth has this shield around it. We call it the magnetosphere. And thank God we have that, because, life might not have existed on our planet without it. But this wonderful shield has protected us from some pretty nasties out there. But if you want to fly your telescopes or humans out to space and take pretty pictures, they need to survive that harsh environment. So there I am. And if you look closely, I am wearing something on my neck. This is a radiation detector that would find out how much protons and electrons I got exposed to, because I took my detector to a particle accelerator, and on the bottom right is the control center of a particle accelerator. This place smelled like vacuum grease, and it just smelled like a lab. It was amazing. It was wires everywhere. And we basically I was told, tune up the beam of protons and destroy the detector. We want to know how far it can survive. And these detectors are now going to fly on the James Webb Space Telescope that is launching this October, the next greatest, largest. I like to call it the origami swan. It's a telescope that unfurls way out in deep space, but it will give us these amazing glimpses into the first, era of our universe. But I was involved in basically screening out the detectors to allow us to observe the universe for a telescope that's way out in space for a long period of time, just to make sure they're robust enough. But that was kind of fun. I've got to dabble in playing with balloons. These are filled with helium, and they rise up to about 100,000 feet, so much higher than an airplane. And I was mentoring a group of students at the University of Colorado, and we were interested in building a star tracker to observe the stars and help navigate, where the payload was, to have it operate during the day. Because when you're up that high, yes, the top of the sky looks dark, but the reflection of the Earth's atmosphere made things a little bright. So that was a fun project to work on balloons. I had another experience where I joined a mission called New Horizons that flew by Pluto in 2015. And what's shown on the left is the path that this spacecraft, the fastest spacecraft we've ever launched, traveling at, I had to look this up, 36,000 miles per hour. We launched it in 2006, and it took 9.5 years to get to Pluto in 2015. I joined the mission when it was between Uranus and Neptune. It was already had been launched, and my job was to calibrate or oversee the calibration of this payload to bring us these beautiful pictures of Pluto that had not yet been explored. And Pluto at the time of this encounter in 2015 was 3 billion miles from Earth. Wow. It took 4.5 hours one-way light to communicate to the spacecraft, 4.5 hours to get back. And there was an issue that happened on the payload about a year out before the encounter. One of the instruments didn't turn on. It's because it got too cold. As you got further and further away from the sun, even though the spacecraft had its own thermal, it had a plutonium, and it was powered by a nuclear power source that gave off thermal energy. But there's things that still happen. So I had to work at what we call a tiger team that went in and tried to diagnose the problem and figure out how to turn it on. And then it turned out it was a software lookup table issue. This is an interesting thing, since your theme today is computer science. It's fascinating how you may have thought of all the different things your computer program can do. But what was wonderful about it, the designer who made the software, all we had to do was we tripped some sort of limit. All we had to do is change that one lookup table, change that limit, upload it, which took 4.5 hours to upload, wait 4.5 hours to know that it got uploaded okay. Then we turned on the instrument, waited another until we learned, oh, it's all fine. And we brought back those pictures. But, we had this tiny spacecraft the size of a grand piano whizzing by Pluto, taking all these pictures. And, I don't know if people recall what happened in 2015, but that little planet, or dwarf planet, depending upon, that's another story. It is an amazing world with glaciers, with an atmosphere. It's got a blue atmosphere. It even, has what looks to be perhaps an ocean underneath. It's a very beautiful beautiful world. And what was fascinating working on New Horizons was 25% of our team are women. And I never really noticed these things as I go through my projects. I mean, I'm surrounded by, people who like to solve problems. We are trying to, advance humanity, putting our best foot forward here in the case of understanding where we're coming from, what we're made of, and how our solar system works. Very scientific, but in order to do these things, we have to do some very good engineering. How can we have things survive in space for a long period of time? How do we communicate? How do we look at the data? And the roles that the women on New Horizons was, we had our scientists and our engineers, our lead mission ops manager, but they actually also were involved in our how we got to Pluto. And to be honest, it was fascinating to learn that we still didn't know whether we would fly by and not get any pictures of the planet, because the planet was so small. We were flying by so fast, and we didn't actually know to the right accuracy where planet Pluto was in the sky. And that's another story. But now it was amazing to see this group of women and men on the New Horizons team pull off an amazing feat. So that was a fun project. A few years earlier than that, I got an opportunity to build a payload that was going to go to the moon. And it was a fascinating experiment. I had never worked on it. It was an impactor. And when I look back at it, I was thinking, this was a classic example of the scientific method. You learn this in school and you're like, why do I need to know this? Honestly, this mission was a textbook example of the scientific method. Scientific method starts with, you start with a question. There's a question you're out to answer, or you pose a hypothesis. what we had learned in the decade or so before studying the moon, that there was these excess of hydrogen at the poles, but not at the equator where the Apollo astronauts had visited. So, but at the poles, it was a very different environment. And there was a question posed, could that hydrogen be in the form of water? Now, if you were to find water on the moon, that could be used for oxygen to breathe, because you break the H2O into H and O. You can make fuel from the hydrogen and oxygen. You can make oxygen to breathe, and you could have water to drink. And, water is a very important thing for not just life in the universe, but also, making things for humans to sustain living in space. And our experiment designed the impactor, sort of like how do you get the basin of these craters up to see what it's made out of? We took the upper stage of a rocket and crashed it into the moon at about 5,600 miles per hour, school bus size thing, and kicked up dirt, moon dust, several miles in the sky. The sun illuminated it. We took some pictures and some spectra, and we did find that there is water on the moon. And so it's been amazing to be part of this chapter of our, we've written a new chapter on the moon now that we found water on the moon. So now I'm working on a mission to map water on the moon. I'm on a mission called the Viper rover. Viper stands for Volatiles Investigation Polar Exploration Rover. Someone has to come up with a name for these things. We're going to make the first maps of water on the surface and the subsurface of the moon. And a few years back, there's a picture of me in what's known as the science support room. We were practicing these techniques by sending a rover out to the Mojave Desert in California. And there I am, personing a console where I am looking at the data from the different instruments. And I'm a deputy project scientist now on the Viper mission, and it'll be launching in a few years. We're building up all the rover, and the instruments are already done, and we're going to be driving nearer time on the moon. Now, this is something that we haven't done before. Yes, we landed rovers on Mars, which was amazing and is amazing. That is another story. But to actually drive, remotely from Earth, and it takes a few seconds to get to the moon and a few seconds to get back, and to go to a place on the moon where we've never been, the lunar poles, where the sun only gets a few degrees above the horizon. So you have these long shadows and you're always working in darkness. It's going to be a very dramatic mission. And hopefully these maps that we will be generating mark the way for successor missions. And if they show there is indeed a lot of accessible water, then we can use those for the moon villages that come next. So just a couple of examples, but I in reflection time, I am extremely grateful for growing up in a country where I have access to education. I was reading your website about Tower Hill. Wow, all these amazing opportunities you have. Soak it in, guys. Soak it in. In this amazing era we live in with these technology advances, it breaks my heart to know that there are still countries and communities on this planet Earth that we all share, where kids, especially girls, don't have access to education. I am so grateful to have my education and have access to it. I'm grateful for my parents who never discouraged me. I'm grateful for my teachers who came to the rescue when my self-doubts consumed me. I am not a highly confident person. I am extremely shy. I'm very introverted. I am a geek and a proud geek. And sometimes your brain tells yourself you're not good enough, and then you start to believe it. And I'm grateful for the times in which teachers during grammar school, middle school, high school, college, and even through my postdoc, they they saw that in me and came to the rescue. Perhaps it was a little bit of encouragement, or perhaps it was a distraction. I mean, it was all different types of techniques. So I'm grateful for that. And I'm also grateful for organizations and some support groups through informal and formal who've helped me get through things when things got tough, because it wasn't always perfect. It's well, that's what life is about. And I also mentioned that I myself am my worst enemy, even today. This being in this virtual environment and not being able to see my friends, my colleagues, and then not having to be able to talk things through properly. I can get very frustrated. And over the years, I've figured out ways to acknowledge that frustration. I've also sometimes used frustration to get it to do things. Frustration has been helpful, but sometimes it can be detrimental, and recognizing when that happens. Because although I may be my worst enemy, when I look back at things, it's been okay. I have used those moments to channel my extra energy and find ways to work through my frustrations. So in closing, epic adventures await you. And today's summit has some amazing speakers and panels, and just, soak it in. So work hard at something you love. And, when it's something you love, these little bubbles, the bumps along the road don't really seem to matter. No job or no class project will ever be perfect. I am a bona fide perfectionist. I've recognized that nothing will always be perfect, and no job or class project will last forever. I've, to have this adventure in science, keep this open mind, stay curious, and never stop asking questions. And one thing that resonates a lot with me is to learn as much as you can at every moment, because you never know what you're learning you might use in the future. Over the years, I have been like, I am so glad I took that class. Oh, I'm so glad I went on that experience. I am so glad I talked to that person. I had no idea that these little bits of knowledge that I've gained over the years would, sum up to things that I tap into today. And on projects I work on, so I work on a lot of different things. I'm not a specialist. I'm like a system scientist. I work on where I could, contribute. And a lot of my colleagues come up to me saying, how did you come up with that idea? And I said, well, when you get exposed to a lot of different projects, you see a lot, you learn a lot, you are processing a lot of things that are coming from all over you might not recognize at the time. And so it's been helpful to be the system scientist versus the expert. We need our experts for sure. I go to the experts to ask them questions, but I know that I'm always learning as much at any time. Plan well, have hope, be persistent, and play often. So you're working hard and playing often, but most important, never stop exploring. So thank you.